Hello dear students, welcome back to Easy Notes. Today we're going to start our part C of this chapter, that is last part of this chapter. A small topic called uniform circular motion. What is uniform circular motion? Let us learn here. Okay, so this is a circle. So what happens in a circular motion or in a linear motion? If you talk about a linear motion, in linear motion a body moves here in this direction with constant speed and velocity. If the body is moving with constant speed and velocity, if the speed is constant, velocity will also be constant because the direction is same, a straight line. Okay, so at that time acceleration will be 0 because the velocity is constant. But what happens in circular motion is, let us shift this here. What happens in circular motion is, here the speed will be constant. What will be constant? Speed is constant. Speed is constant. Now the speed is constant, but what about velocity? Is the velocity constant here? See, at this point, the velocity will be directed here. Velocity is always tangential to the surface. Okay. At this point, the velocity will be directed here, and at this point, the velocity will be directed here. Similarly, at this point, the velocity will be directed here. It means that velocity is changing its direction everywhere. So velocity is variable. Velocity is what? Variable. Now, if the velocity is variable, the acceleration is non-zero. Acceleration is not equal to 0. But where does acceleration acts? There are two types of acceleration here. Okay, one is tangential acceleration. It acts about the tangent AT, and the other one is centripetal acceleration, which acts about center. Tangential we won't learn here, but centripetal we learn here. Okay, so centripetal acceleration is something which act towards the center. So it helps in controlling the body in moving in circular path. Okay, so there is a centripetal acceleration called, and there is again two types of acceleration, tangential and centripetal acceleration. The total acceleration will be somewhere here, net acceleration, and the acceleration is not 0. Okay, so uniform circular motion is an example of accelerated motion. It is an example of accelerated motion. Accelerated motion. So these are the things mentioned here. When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. Uniform means same. What is same here? Speed is same here. Okay. Direction of velocity at any instant will be variable, because in a circular motion is an accelerated motion because the direction is variable even though the speed is constant. Even though the speed is constant, circular motion will be variable. But in linear, see here, in linear motion, if the speed is constant, velocity also becomes constant, so acceleration will be 0. But here in circular motion, even though velocity is constant, acceleration will be there because of, even though speed is constant, acceleration will be there because of velocity. Velocity is variable due to direction. Velocity due to direction. Okay. Next, difference between uniform circular motion and uniform linear motion. In uniform linear motion, both speed and velocity are constant, meaning acceleration is 0. Okay. However, in uniform circular motion, while the speed is constant, the direction of motion continuously changes because the velocity is a vector quantity. This continuous change in the direction of velocity means it is variable, making it an accelerated motion. The same thing we have learned here, right? Linear will be unaccelerated motion, but uniform circular motion will be an accelerated motion due to variable velocity. Okay. Next, we'll learn about centripetal force. What is centripetal force? The force due to centripetal acceleration is known as centripetal force. What was centripetal acceleration? It was acceleration which was acting towards the center of a circle. Similarly, what will be a centripetal force? The force which is acting towards the center of a circle, which helps the body to remain in a circular motion. Okay. So in a circular motion, at each point of circular path, the particle continuously changes its direction of motion. This change in direction of motion cannot be brought without a force, right? If there is an acceleration, there will be a force. Thus, the motion is a circular path. Thus, the motion in a circular path is possible only under the influence of a force, which is termed as centripetal force. That force is known as centripetal force, which helps us in moving a circular path. Okay. At each point of circular path, you just learn this. Same thing he is telling that every particle to remain in a circular path, we required a force known as centripetal force. Okay. Now, there is another type of force called centrifugal force. It is also a pseudo force. What do you mean by pseudo force? Pseudo force is something, a false force. There is no origin of this force. It is present, but it will be present. It will be present when? It is present in non-inertial frame. What do you mean by non-inertial frame? Non-inertial frame means where acceleration is present, variable. Acceleration is variable. See, centripetal force can be seen when we are standing away from the circular path. See, I'm standing here and I'm seeing anything rotating here. Okay, we'll see that there are some strings which are attached to the center that are helping it to rotate in the circular path. But in centrifugal force, we'll be inside the car. We'll be inside the car. So what happens? While sitting inside the car or in a giant wheel, you sit, right? Have you sit? So what happens in that? There is a force acting away from the center. If by mistake, what happens? If the brake fails here, what will happen? This car will move away from the center, not towards the center. While turning, what happens? While turning from this road, while turning, if the speed is more, you will go this side, not this side, right? Why you will go this side? Because there will be a force called centrifugal force, which will be acting away from the center. Centrifugal force will be acting away from the center. When it will be acting, see, a force acting on a body away from the center of the circular path is called centrifugal force. Thus, the centrifugal force is in the direction opposite to the direction of centripetal force. Wherever the centripetal force is acting, it is opposite to that. Centripetal force will be acting towards the center and it will be acting away from the center. Its magnitude is same as centripetal force. Both have magnitude of mv square by r. But centrifugal force is not a force of reaction of centripetal force. We might think because of centripetal force, we are developing a force known as centrifugal force. But that's not, they are not relatable, okay? Because action and reaction do not act at the same body, right? See here, if I keep this pen here, the pen is applying the force on my hand and the hand is applying force on the pen. These are action and reaction. They both are acting on the different bodies. Here centripetal and centrifugal force are acting on the same body, that means on the car, right? So they are not action and reaction. Okay, remember that. It is not the real force, but it is a fictitious force assumed by an observer moving in a circular path. It is assumed by an observer moving in a circular path. If you are in that path, if you are in non-inertial frame, okay, if you are in that frame, then you will feel that yeah, centrifugal force is acting. If you are not in non-inertial frame, you will see that only centripetal force is acting on a body. Like if you usually if we see a solar system, right? Whenever we draw a solar system, we draw it as like center is a sun. Here there will be rotation of different planets. We'll see that there is a force in between them that is known as centripetal force. Okay, now if you sit on any planet, then we'll experience a force away from the center. That is nothing but centrifugal force. If you are present in the non-inertial frame, we'll feel centrifugal force. If you are not present in the non-inertial frame, we'll feel centripetal force. Note, the magnitude of the centripetal force and centrifugal force is same, that is mv square by r. Next, some PYQs. A stone of mass m is rotated in a circular path with a uniform speed by tying a strong string with the help of your hand. We have tied a strong string to the stone and we are rotating like this. So what happens? Is the stone moving with a uniform or variable speed? Speed is uniform. Speed is uniform. As they have mentioned here itself, that the speed is uniform. Okay. Is the stone moving with a uniform acceleration? No. In which direction does the acceleration act? Speed is not moving in a uniform circular motion. Answer will be no. And in which direction the acceleration acts? Acceleration will be towards the center. Okay. It's nothing but centripetal acceleration. What kind of force acts on a hand and state its direction? What will be the force acting on our hand? See, we are holding the string, right? So the force acting will be tension force. What kind of force? It will be a tension force due to string. Okay. And what will be the direction of force? See, as soon as the string get released by our hand will move away from the center, right? See, we are rotating like this, it will move away from the center. So the direction will be opposite or away from the center. Away from center or string, anything we can say. Okay. Next. A body is moving in a circular path. Okay. How does this principle apply to the motion of planets in our solar system? Simple thing, right? we know that there is a sun in between, and planets almost revolve in a circular orbit. Almost, I'm saying, not accurately. It revolves in an elliptical orbit. Almost, we can say that it revolves in a circular orbit. Okay, so planets revolve like this. So, which is the force required here for planet? In between planet and a sun, there is a force known as gravitational force, which is holding them to revolve in a circular orbit. That force is nothing but a centripetal force, which helps a body to revolve in a circular path. Okay. Next assertion: in uniform circular motion, acceleration is zero. No, this is wrong. Acceleration is non-zero. Why it is non-zero? Because the velocity is variable due to its direction. Next, speed is constant. Yeah, speed is constant in uniform circular motion. So assertion is false, but reason is true. Option D. Okay. Next, match the following. Centripetal force, inward force towards the center. So first one is B. Option A and option D. These two are wrong. Centrifugal force, away from the force, right? Away from the apparent outward effect in a circular motion. So second one is A. So option A will be the answer. See, torque. What is torque? Force into perpendicular distance. Third one is D. Center of gravity is point through which weight acts. Fourth one is C. Translation motion is all particle move parallel in the same direction. Yeah, option 1 is correct here. Easy? Everything done? Now we have completed with the first chapter. Revise everything from this chapter and be prepared for the next chapter, that is work, energy and power. So let's meet in the next chapter. Till then, keep studying, keep supporting. Bye bye.